There are a variety of specific attacks that you need to know how to mitigate. Stick around to find out how.
You're watching IT Pro TV.
Hello, ladies and gentlemen. Thank you for joining us for more CySA Plus, and that's right, we're diving into very specific attacks. And I tell you what, this first one up, I know a lot about this language, and what I mean by that is that it configures our systems in Windows, but you can be attacked with it as well. So, Dan, tell me a little bit about XML-based attacks.
XML-based attacks. Yeah, let's hit that ground running. We do have quite a few to get through, so we are going to churn and burn. With XML, a lot of times what we're speaking about specifically is XXE, or XML External Entities attacks. And yeah, it's a lot of fun. There's a couple of things that could happen with these. You can do some file reading of sensitive information. You can perform denial of service attacks. And there's also even some code execution, command execution types of attacks, which you can use through the vehicle of an XXE. And basically what's happening is you're able to define your own XML entity through your own DTDs. You feed that stuff into the system and it just parses it and feels like it's actually from the programmer of the system itself. It doesn't see any difference. So let's show you what an attack can look like, and then we'll talk about mitigation. So let's jump into my computer. I've got, I can never say this correctly, but it's you can find it out there in the wild. It's Mutilidae, I think, is how you pronounce this. But it has all the OWASPs from years past and has a bunch of attacks that are purposefully in here, or vulnerabilities are purposefully in here, so that you can practice these type of things. Here we are with the XML validator. So what we have is an XML parser, and it will actually take in XML and then see if it can validate that XML to make sure there's no problems with it. The problem is that I might be able to exploit that. You'll notice that right here, I've created this doc type hacker, and then I've created my own entity called goodies. And if it works, I will get to read the etc password file, right? And then down here, I just took this example code that it gives us, this hello world, and instead of hello world, I put this right here, which calls my own entity. If I click then validate XML, scroll down, and you will see that I am now reading the etc password file. I'm seeing all the entries for that system. That is an XML entity attack. That's typically what you'll see as far as an example for that. But like I said, I could create a denial of service attack with this, where it will expand. Typically, you'll hear it as the billion laughs or billion LOLs, something to that effect, where it'll expand out an actual billion different pieces of information, which will overwhelm your system and make it crash. So be on the lookout for those. Mitigations, don't use XML. There's that. If XML causes the problem, you know, stop doing it. Doctor, it hurts when I move my arm like that. Don't move your arm like that. I know it's a joke, but it's, I like talking about these with Justin, because Justin's like, who uses XML anymore? You know, stop using XML. We have other things that can do this, like JSON, and you don't need XML. If you're stuck in one of those positions where you are needing to use XML, or you're confronted with an XML-based system, make sure you're using something that's up to date. If you're using a SOAP environment, which you probably are if you're using XML, make sure you're using 1.2, version 1.2 or higher. And make sure your parser, check and see if there's any kind of update to that system to see if maybe you want to move to a different XML parser so you don't have this issue, because some of them don't. They've been fixed to where this won't happen. So there you go, some basic mitigations to defend against XML attacks.
Dan, one of the things that we use, one of the technologies that we use is a way to store our information in a very structured fashion, right? Relational databases, right? So think of things like standard querying language, SQL. There are a lot of SQL attacks that you have to worry about. Dan, can you speak to some of those?
Yeah, let's jump into XML. I've got XML on the brain now. SQL injection, SQL injection. Let's jump into the computer really quickly. An easy attack right here. I've got the DVWA up. If I put in what is that, a single quote, and then or 1 equals 1 kind of thing, you hit submit, you'll notice it dumps the whole database out. That's a SQL injection attack. I'm feeding it SQL. So what do I do to defend against that? Well, there's a couple of things you can do. You can sanitize input. That's probably your best bet to defend against these. Use of prepared statements or just validate that the input that's coming in, I guess that's part of sanitization, is what you want it to be. Why am I feeding it characters, or why is it interpreting characters such as a semicolon? If I'm looking for an ID and that ID should be a number, so if I put in 1, that's what it's looking for. So it shouldn't be accepting things that aren't numbers. And if you look down here, that's what I kind of love about DVWA. You can look at this view source. Let me pull this over here. And this, let go. And this is the source code that actually runs this. I'm going to do this. And then you compare all the different security levels. And as you scroll down, you can see some of the implementations of security that they've used to try to keep it from happening. So it starts looking at this session ID. It's checking the database. This is for a high SQL injection. And I want to look at the impossible one because the impossible one is like crazy. There you go. It's getting the ID. And you'll see right here, checks, is it numeric? Oh, maybe you can't see that. There you go. If it's not numeric, it's gonna error out. And that's what you should be doing. So what it's saying is, if it's not a number, if you're giving me other characters than numbers, I'm not gonna work, right? And it just took a little bit of logic to make that happen. You can also just implement something like a WAF, which has all this kind of built in. That's probably one of your best bets against something like SQL injection.
Now, the next topic, you might say that there's so much information in it that even the cup can't hold it, right? And what we're talking about here is the various types of overflow attacks. You've heard Dan mention them throughout the series. Now, Dan, there isn't just one type of overflow attack, right? There's multiple.
No, there's a few. Yeah, we got to be on the lookout for these things. With overflow attacks, just really quickly, you want to be on the lookout for stack-based overflow attacks, which are in dynamic memory. You also have heap-based, which are in static memory. And you have integer-based, which basically means I'm giving you something, an integer that you can't deal with. It doesn't know what to do, and therefore it kind of weirds out the whole system.
So like I'm expecting 8 bytes, but I deliver 9 bytes, and it goes, what the heck do I do with this other one?
More like a number. Like,
just a number.
So if I say I can only take a 2-digit number and I give you 3, what happens?
Ah, gotcha,
Right?
gotcha.
If I give you, if it's looking for a positive integer and I feed you a negative integer,
What do
or
I
a
do with
decimal integer, what do I do with that?
Gotcha, sure.
If it doesn't know how to deal with that information, it doesn't error gracefully, then you could possibly have an overflow issue right there. So some of the protections that you'll see for, or mitigations you can implement against this is secure coding. Obviously, you have applications. If you're building applications, your coders need to be implementing the most secure coding practices possible. And with that in mind, things like ASLR, which is address space layout randomization. This is a fun thing that when I was learning how to do exploit development, was that some programs that don't have things like ASLR will say, here is the memory space in which I want to put this. And it is consistent. And if I can predict where that's going to be, then I can manipulate the program if I find a place to inject input. Okay. So actually, if we look at my computer, I'll show you one of the exploits that I've written for a very simple network-based server. There's all the shell code. It's not really super important right there. You know, you're like, what is all this? This is really the meat of what we want to look at right here, because that's the attack. And in there, you see this address, this hex valued address. That's actually the memory address where this program sends information that I need to be specifically aware of. I want to be able to do what's called a jump ESP into another register and then execute the code that I put in there. Okay, and that is where that memory address is. If I change it, if I make it random, where it's not the same every time, that will protect against these type of attacks. All right, other things you can do will be use a stack canary, which looks for buffer overflows and then alerts the user to an overflow that's having trouble. Also DEP, which is data execution prevention, which is something that's implemented in Windows programs. And of course, do your SAST, your DAST, where you're actually looking at the code, looking at it statically, looking at it dynamically while it's running, seeing how everything works, looking for those overflows. If you know that they're there, then you can mitigate for them and fix them. Switch programming languages, some of them just have problems by default, like C. They have built-in functions that if you use could leave you open to these things. So you could just jump to something different like Python. Use that, program with that, and you won't have those issues, right? So you just move them.
So this next attack, I've actually heard and read an article where somebody could craft a malformed RDP packet and send it to a Windows server And through that, they could launch off into the next type of attack, and that's remote code exploitation. Can you speak to that?
Yeah, there's quite a few of these types of attacks. This is what's called remote code execution, or RCE. If I bring up, let me shrink this thing here. And I've got Metasploit up right here in this lovely little box. And I've already found, this is the Eternal Blue exploit, and it is tiny. Not command, what am I doing? Control plus plus, shift control plus plus plus. There you go. A little bit better. I've already set this thing up, and what it's going to do is basically, it's going to exploit a known vulnerability in a Windows operating system, if everything goes correctly. And if it does that, what it will do is it will add the user hacker with the password of Darth Vader, all leads spoken, right? There you go. A little bit easier to see. So this is remote code execution. There's a vulnerability in the system. Could be RDP. This one is specifically SMB based, but it allows me to run system commands from a remote location. Remote code execution. There's the idea. If I, let's see here, if I go ahead and type exploits, there we go. Looks like it's trying to contact the targets. Service. So we're basically waiting for this to run. If all goes well, I'll be able to jump onto that target system, and there should be a new user in the system named hacker, right? Let's jump over there. Here is my Windows 2016 server. Let me log in. And we can see I've already brought up the users. We've got the administrator user, we've got the default account, guest, and the Kerberos user, right? Let's do another net user. And now we see we have hacker right there. So I was able to remotely create that account. So remote code execution is something we've got to look out for. The mitigation for this, patch the system, right? A lot of these will be 0 days, but some of them will be known. And all you have to do is find the update or use a different system. But typically it's going to be an update to the system. Once these types of RCEs are discovered, the vendor typically is on the ball with trying to patch that so this is no longer effective.
So when users have access to our systems, maybe it's a customer, we want to make sure that they're confined to the specific locations that we intend them to be, and they can't go sightseeing through our platform. Can you tell me a little bit about directory traversal?
Yeah, directory traversal, common web application attack. Let's go into our web application and just kind of show you what that looks like. I think they've got one in here somewhere. Inclusion of upload. This one doesn't. Let's go to... bring up the BWAP. I know it's got one. Where are you at, BWAP? Excellent. So here we are, log into the BWAP with B and bug, because it gives you the credentials right there. Find RFILLL. Okay, don't be that way. Be nasty to me then. There we go. Remote and local file inclusion. Hack that. Here we are, we're looking for a file. If I try to change this and I hit go, you'll notice that up in the URL, it's got language equals, and it tells me the page itself, right? This is the page that it's pulling. What if I change that to /etsy/password and I hit go? Well, hey, look at that. There's the Etsy password file. So I'm able to do that. Sometimes you need to actually like back out of the directory. You need to traverse directories. To do that, let me get back up in here. To do that, I'll just do .. // and then I would be able to do the same thing, and it would actually, back out of the directory that it's currently in, that context, and then move back down into the directory that I'm giving. So that's a directory traversal attack. This can actually lead through, this is also called local file inclusion, remote file inclusion. This can lead to remote code execution as well, or remote command execution, which could give me access into the system. Very important thing. Again, you're going to want to sanitize data here. You're not going to want to trust users. This is what a lot of web application stuff boils down to. Don't trust your users. And that just means that whatever can come from them should be treated as possibly wicked, if that makes sense. You want to give it a parameterized thing, use a WAF, something to that effect, do some sanitization, use a filter that takes out those special characters, maybe some encoding. Those types of things will help you not fall prey to these types of attacks.
You know, in other systems, I think of like Nix-based systems and Windows systems, we have things like standard user, we have the root user, right? We make sure that we drop down to sudo, or we have the user account control. But even with all that, we still have to worry about privilege escalation, don't we?
Yeah, privilege escalation, always a problem, right? Because once I've gained access into the system, well, I'm going to want to get that admin cred. And ultimately, a lot of the mitigation that comes down to this is going to be with permissions, and it's going to be with updates. So it's probably the two big hitters, that if I have a system that has a privilege escalation vulnerability based off of the kernel or whatever, then hopefully my vendor has supplied a patch and I can just download and install that patch, and then I'll be safe, right? So think of things like Dirty Cow. Dirty Cow was a very popular and very effective means of privilege escalation inside of Linux operating systems. But there's now a patch for them, and therefore, if it is patched, I won't have that problem. The other will be, like I said, in those permissions area where I don't want to set SUID and GUID permissions on something that I haven't really vetted as far as whether or not there could be a possible privilege escalation attack via those means. Sudo is another great one to mess up, where if I give someone sudo permissions, remember, they're elevating their privileges into the context of root or systems privileges, and therefore, if they're able to manipulate that in any way, it might give them permissions. Now, you do have vertical and horizontal and vertical permissions, right? Where horizontal will mean I'm a standard user, and I gain Wes, who is also a standard user, I gain access into his account. That's a horizontal move, right? But he might have some access that I don't necessarily have access to. But ultimately, I want those vertical permissions where I'm actually going up into administrative or more privilege up the chain there, ultimately leading to system, right? So that's the privilege escalation attacks you need to be worried about and how you can mitigate against them. Just get those permissions right.
We've seen one of those files that you definitely have to keep protected, right? Etsy password, even more, right? The shadow file there too, and that's to protect against this next type of attack called password attacks, right? And we can also have to worry about things that automate this, right?
Yeah. So with password attacks, this is the oldie, the goodie, the greatest one. We all hopefully understand this by now. This is doing, well, I'm going to brute force a password. Maybe I've got, like Wes said, a mechanism for logging in, authentication, SSH, RDP, whatever. I can use mechanisms like Hydra or Medusa, Potator. I know that sounds weird, but it's a real thing. Potator. It's weird. But it allows me to brute force those systems to try to gain access. So what does that boil down to? It boils down to we need strong passwords and strong authentication mechanisms so that they can withstand those types of attacks. So a couple of the favored sons of password attacks right now is going to be credential stuffing and password spraying, right? So with password spraying, I always get these two confused, so I put them in order so I don't forget. Password spraying, using commonly known passwords to attack known user accounts. And then credential stuffing is if I've discovered or gained a set of credentials for a known user, I'm going to go after other systems because they're not reusing those credentials, are they? They probably are. And that will allow me to gain access into those systems as well. Just because I have one set, I now have keys to many different things. So that's the difference between credential stuffing and password spraying. Just make sure you got good password. Implement 2FA, MFA if at all possible and everywhere that is possible. And that should help mitigate that. You can also use things like fail to ban, where if someone's trying to brute force either a dictionary or just a standard brute force type of attack, it will stop them after X amount of tries and then lock that user out, and they'll have to contact the help desk to get unlocked. And that will inform you that something is happening with that user's credentials.
All right, speaking of help desk, I've just received this email and it's telling me it's coming from help desk and I need you to reset your password here because we need to help you out. Tell me about this next attack. And what I'm saying is not phishing like you might think, but impersonation. Tell me a little bit about impersonation.
Yeah, so typically impersonation is used with the business email compromise or BEC type of attacks, where you get an email. It looks like a phish, got spelling errors, weird requests, but the email account is legit. It is literally coming from, Sally, who's head of finance. Great. Should I ignore that? What should I do? So people can fall prey to this because it does look like it's coming from the right person, because technically it is. And it's an impersonation. Someone has gained access of your system and they use that access to impersonate you to other people for malicious reasons, right? So that's what we're looking like. When it comes to mitigations on this, security awareness training is probably going to be your best bets, where if you see something weird, say something to somebody. You can go and ask them, hey, Sally, you sent me that email asking me to transfer $10,000 to this account. Did you really? It seemed weird, especially since you misspelled your name. Very strange. Just that security awareness is really going to help you out with those types of attack. Knowing that if something is weird, that's a good indicator that something is weird, and you should probably do something about it.
If I can sit in between the source and the destination of a communication, chances are I can do a lot of damage if I wanted to. Tell me about an MITM, or the man-in-the-middle attack.
Yeah, man-in-the-middle attack, very common way to attack a system where if I'm on the same network, I have access to both systems where we're all kind of in an area we can communicate with each other in some way, shape, or form. I can tell Wes that I'm Facebook, right? And he'll start sending all his Facebook traffic straight to me. And then I tell Facebook, I'm Wes, and I'll redirect all that traffic back out to them. And they'll go, oh, that's awesome. But the whole time I'm able to read and intercept that information and even modify it. So Wes thinks he's good to go. Facebook thinks they're good to go, but I'm in the middle stealing information, modifying information, especially if it's something like a bank account that could be really problematic. All right. We don't want somebody doing that. It could be a real issue. So man-in-the-middle attacks are very common. We see it was like ARP cache spoofing, DNS, man-in-the-middle attacks. It's where that gives you that type of access. So I'm just telling them that I'm that individual. For that kind of stuff, turn off dynamic. Make sure that there's static entries for everything that you need. That can be a bit of a heavy lift, but it's something you need to be familiar with. Firewalls, next-gen firewalls can help with stuff like this as well. To be on the lookout for multiple entries for same thing and rapid changes, and the traffic that's coming across the wire should be able to help you mitigate those things. But those are the type of activities you want to engage in to mitigate a man-in-the-middle attack.
So Dan, you talking about man-in-the-middle, I was thinking, well, what if you happen to grab my session information and store it in your back pocket, and then you reuse it? What happens when it comes to session hijacking?
Yeah, great. And because man-in-the-middle and session hijacking usually go hand in hand, so it's a great segue into that. With session hijacking, basically, I'm getting your session information, typically through some form of cookie or information that is being sent through the browser to a web application. And now, if I'm able to sit in the middle and snatch that information or get that information in some way, shape, or form, I can then inject it into my request to that application and will think that I'm you. And I know it sounds like an impersonation attack, but it's a little bit different. So let's jump into my computer again really quickly. I've used Burp Suite to capture the information. I know, wicked tiny, right? Don't worry. And you'll see right here, so this was the RFI, LFI attack that we sent, looking for that Etsy password with that directory traversal information. But right here, you see PHP SesID. And there is the session cookie for the user that contacted that application, logged in, and sent the information across the wire. If I'm able to grab this information through a man-in-the-middle attack, or maybe even cross-site scripting, we'll talk a little more about that in just a second, I can then inject that into my browser, say this is the cookie for this page, and it goes, oh, you're Wes. Hey Wes, how's it going? Here you go, access to Wes stuff. I'm not Wes though, right? I'm me. I'm the hacker. I'm whatever. So we got to be on the lookout for that. Some ways that we can help protect against this type of attack specifically is going to be encrypt that cookie transmission. Make sure that all this information isn't easily just read because it's clear text. Delete cookie from the browser cache. So as the browser will store these things, and as you go back, it goes, oh, there's your cookie, and it just continually reuses the same information. So typically use that so that you don't time out. You ever notice that you go to Facebook and you've never logged out? Like ever, because I think their sessions are 10 years. That's a long time, right? But if I'm able to get a hold of that session information, I'll be able to log in. You'll never be none the wiser, right? And then require a new cookie for each session, right? So time those sessions out. If I'm not on, if I'm not active, or if I've closed the browser, it should just delete that browser session, and then you'd have to create a new one. And if you go into sensitive information, it should ask you for more information and give you a new session ID. Again, continually authenticating you to who you are. That helps mitigate those types of attacks.
This next type of attack I've always thought as kind of interesting in the fact of what it's called, because today when it affects a Windows, it probably shouldn't be called that. What I'm talking about is a rootkit, because there is no root user in Windows. Tell me now, these are very privileged attacks. Tell me about these.
So
Dan.
crazy. So rootkits, they're one of the toughest things in the world to get rid of. but they're not that difficult to mitigate against. So let's talk about what a rootkit is. Basically, it's a ring 0. This is full system access, kernel level access to your system malware that digs itself in and it has complete control to keep itself there, which is why it's really a pain in the tuchus to get rid of, right? If you do find yourself with one installed. But to keep it from being installed, use anti-rootkits. And most anti-malware and antivirus software nowadays will have anti-rootkit implementations in them. So if you're using a good quality antivirus, anti-malware, maybe EDR or EDM, not EDR, the endpoint, the big endpoint systems. So endpoint protection basically is what I'm looking for. If you're implementing one of those, you're going to be a much better way than you would be without them. That is for sure. They are great tools. That's going to be what you're going to want to lean on for anti-rootkits. If you do find yourself with one installed, man, I don't feel good for you. I feel bad for you, real bad, because I've dealt with them before, and they get dug in. A lot of times, it just goes to blasting the machine. So we really want to stay away from getting rootkits installed, and we do that by making sure we have a good antivirus systems and endpoint protection on our machines.
So my workflow for the last 4 years is I log into my computer in the morning, right? And I fire up this website. I know it's benign. I trust it. And all of a sudden, out of nowhere, I've got JavaScript, executing on my, my machine somehow. Tell me a little bit about the cross-site scripting attack. This one seems scary.
Yeah, this one can be a big deal. Cross-site scripting is, bug bounty guys say, cross-site scripting pays the bills, right? Because they're very hard to remove, and they're easy to create a way from which you could use them. So cross-site scripting, we got that in DVWA. Let's take a look at that really quickly on how that attack works. We've got a couple of input fields here. I'm just gonna make it a little bit bigger. And right, I love it when it does that. Here we go. And I know in this one I don't have a lot of characters for the name, so I'm just gonna put a name in here. We'll call it hacker. And then down in the message, if I put in some JavaScript like script alert, this is a common way to test for cross-site scripting. Ding, ding, ding. Nope. Script. Close my script tags. And then sign the guest book. You'll notice that this pop-up comes up, right? I was able to have the web app take my third-party input and treat it as JavaScript code, and it executed it. That's why that alert popped up with what I told it to pop up. Not only that, this is a stored attack, and anybody else that goes there, like somebody else is logged in, I'm on my MacBook. If I go down to stored, of course I'm logged out, admin and password. Now if I go to stored, where are you at? Bang. You'll notice, look at that. I got hit. Now if this is malicious code to steal cookies, well now I've got the makings for a great session hijacking coup de grace, right? So if I use some fancy JavaScript to steal the session cookie and send it back to my evil web server to grab that information, I can take that cookie and insert it into my browser, and I've got a great session hijacking going on. Now I'm able to log into whoever this user is and use their credentials to do a myriad of things. So this is a very common yet very dangerous thing. We're going to want to mitigate, right? Mitigations are going to be sanitized user input. We're back to the oldie but goodie. Don't trust your user's information because they might be an attacker. And since you don't know whether they're an attacker or not, you have to assume that they are. You always have to assume the worst if you have lack of information. And the worst would be that they are an attacker. Therefore, I'm going to sanitize the input. I'm going to use a web application firewall to do that, or create some sort of regular expression filtering. I'm going to create specific strings that are only allowed for those entities, and that's going to help mitigate these cross-site scripting attacks.
All right, ladies and gentlemen, there you have it. We have a lot of different specific attacks that you need to be aware of. And for the exam, if you're given a scenario, be able to know how to mitigate these attacks. It's going to be important to your success on the CySA Plus exam. Now, speaking of CySA Plus, I've got a lot more to say. Not enough time in this episode. This is one of those episodes jam-packed with a lot of good information. We have a lot more information to jam-pack in some upcoming episodes. Hope to see you there.
Thank you for watching IT Pro TV.